And this is 3/6 alpha. So I want you to do this, please. Once you get on your calculator, we're going to start at the end. We're going to start with this question, which is number 72. Right? So the parent graph is y equals the tangent of 4x. And then you put the derivative in y2 and turn on your y, whatever you have the derivative in, and see if the table's right. Okay? What is the derivative of the tangent? Let's go. What's the derivative of the sine? Cosine, yes, that's the one. What's the derivative of the cosine? Negative sine. Tangent's a little hard. Very good, secant squared. You memorize these yet? Apparently not. They're not waiting for you. You got to, I don't think. There's going to be more stuff to come. You can't just kick this down the road. Secant squared. So you go to your calculator and you do this. You go to y equals, and I type in tan 4x, yes? And you get down to y2, we're going to turn this off. You get down to y2, and you push the secant button. Where's the secant button? Let's go. Where is it? Find it, Woody? Where? Who knows where the secant button is? Anna. That's inverse cosine. There is no secant button. Trick question. Why not? Because of the array. You're going to say you knew that? Ready? The array is this. Sine theta, cosine theta. Tan theta, cotan theta, secant theta, cosecant theta. We don't need a secant button because we know what the reciprocal is. So we go here and we type. Ready? 1 divided by cosine 4x. Now, when you square this to get secant squared, you have to square outside the parentheses. That makes sense? Like when you do this, in the textbook, they put the exponent in here. Your calculator doesn't do it. You should make sure where you put the parentheses outside or the exponent outside or inside the parentheses. We good? So we just differentiated that. So we have y6 turned on. Second table. Problem. They don't match. Okay? So it wasn't that easy compared to what you just did. They don't match. So let's back up. You don't do this, just look up here. If I went here and said, let's make it tan x, and 1 divided by cosine squared x, and I go up here and I turn off y1, they do match. So the derivative of tangent is secant squared. You agree that it looks like the 4 is the culprit here. Right? We got a problem with that 4. What's going on? And that's what this is about. So, chemistry. You did dimensional analysis. That's what we're doing here. Dimensional analysis saying we want dy dx. We want the derivative of y with respect to x. That's going to be equal to dy du times du dx because these reduce. And another way of looking at that would be saying composite functions. The inside function is g. The outside function is f. So in that case, what's g? In the problem you just saw, g of x is 4x. And f of x was tan x. So what happened? This went in there, and it became tan 4x. Recognize that? So if we want the derivative of this composite function, it would be the derivative of f with respect to the inside times the derivative of the inside with respect to x. Good? So what are we missing? We're missing the derivative of this. What's the derivative for x? 4. So if we turn around and go back here to the calculator, we insert the 4. There's our 4. 4 times the numerator. Yes. Turn this off. Nope, didn't work. What's the matter? The derivative of tan 4x would be 4 times secant squared 4x. Sorry. The input should be 4x. Here the tables are. You're missing that 4. So what's happening here is the chain rule is saying you have to multiply by the derivative of what's inside. But up till now, the derivative of what's inside has always been a 1. So you didn't need to multiply by 1 because it's got identity element multiplication. Because all the problems you were given, the derivative of what's inside has been a 1. And now you're moving past that. Right? So here's the example. Now, this example is essentially like the example you got for the product rule. And you got a layup example for the product rule. You remember back then when we said we could just use a lattice to expand the question, the 2 factors, and just use the power rule. People said, oh, good, I'll do that. I don't want to do this product rule. But you saw that was just a question to get you off to a good start. Same thing here. So here's the question. 4th power. Differentiate it. 1 degree less. Good. Yes, but how does that help me understand the chain rule? Because if I want to do this, I can rewrite this. I'm going to make the problem harder than it is, just to get an idea of the chain rule. I go over here and I say, 9x to the 4th is an artificial promise, built to work out. 9x to the 4th plus 6x squared plus 1. If I try to factor that, if it were a perfect square, if it were, it's an artificial problem. If it were, then 3x squared multiplied by 9x to the 4th, 1 times 1. And these two cells would have to add up to 6x squared, which they do. So therefore, we could rewrite the question as y equals 3x squared plus 1, the quantity squared. It's the same question. You're going to get the same answer. But we could use the chain rule here, which we didn't need to here. So that chain rule, ready? We say, what's inside the parentheses is mu. You differentiate it with the power rule. Y equals mu squared. What's inside the parentheses squared? Differentiate that, power rule. So here's the dimensional analysis. Now, you might think this is over the top. It is right out the dimensional analysis until we get to the quiz. And if you think, hey, you don't need it, that's fine. But if you skip steps, you're jeopardizing your success. So I want dy dx. dy d mu, so you can use reduce out, that's the dimensional analysis. Dy d mu is here, it's 2 mu. Except I can't write a mu in my answer because you introduced the mu. So it's just 2 mu, it's mu, it's this. Times d mu dx, which is this. Distribute this, distribute the 12x over what's inside, and you get to the same answer. Okay? Now, I'm just warning. Problem 5 is harder than this. Because problem 5 involves, don't blame me, the culture second. Problem 5 involves two things. It's still something squared, so it's going to look like this. But it involves the quotient rule and it involves the derivatives of the trig functions. So you're going to find, I'm leaving it up there as your model. This is your model over here. Because this will help you do problem 5. We're going to pause the video and you're going to 5. We'll see how close we are. Okay, so here's what we're looking at. The textbook gave you the prompt. We're telling you this is mu. Two things, quotient rule, derivatives of the trig functions. You take the denominator and you square it. You take the denominator and you paste it up here. Times the derivative of the numerator, derivative of sine is cosine. Subtract the numerator times the denominator, which would be 0. The derivative of cosine is negative sine. So now what happens? This is just a sine. Cosine squared plus sine squared is Pythagorean identity. It's just a 1. So you have cosine plus 1, which is 1 plus cosine. Divided by 1 plus cosine squared. That's going to reduce. The numerator is going to reduce with one of the factors of the denominator. The big picture is y equals this thing squared. So that derivative is 2 mu. So it's 2 mu times, after this reduces this, and then what? I can't have a mu in my answer, so I put what mu equals. And if you got it this far, that's 100% correct. This is just algebra 1, clean it up. You want to see where your answer may have diverged from this. And then I just verified it with us using theorized derivative of y4. Just a picture of the table. Okay? So we're moving fast through this. But you've got tomorrow to come back to this example and look at this at your own pace. This is, chain rule is as important as anything you're going to do. Question? Anybody not see where one line went to the next? Way up top? Denominator squared. Denominator times root of the numerator. Subtract. Numerator times root of the denominator. Okay? So you can, ready? People are writing, that's fine. I'm more concerned with you reading. You can write this down on your own time. You get a whole day tomorrow. Look up there and say, all right, before I write this, do you see what, tell me where this went to there. Example 3 is what? Example 3 is taking the trig derivatives, parametric motion, and the chain rule. So you see how this stuff is scaffolded. You're not going to do this. You just watch this. I'm going to go to the calculator. And it tells me the position is cosine t squared plus 1. I'm going to go along the line, y equals 2, whatever. We good? Push graph. It's not going to work because I want this to be the bouncing ball. Push graph. There goes the ball. Whoa. Why is the T-map so high? So now what? Whoop. So now I'm going to get a y equals, and I'm going to turn on 4 and the x and y for 4. Because why? Because that's going to leave a path. This graph, there goes the first one. Oh, that's what happened. See, it started here, went left, right, left, right, left, right. You see what's going on? Here's where it starts. It's all traveling that line. So it starts this far to the right of the y-axis, goes left, then goes right. Yes? Which is much easier to see than trying to follow the ball. So that's what we're asked about. And the question says, in example 3, find the velocity. What was the velocity of this thing? It's a composite function. It's the cosine of this. 1 point, what's inside the parentheses for you? I'm just going to differentiate vertically. U is t squared plus 1. du with respect to t is 2t. The derivative of the cosine is negative sine. So that dx dt, the velocity which is traveling horizontally, would be negative 2t sine u. U is that. That's the velocity. Think about this. When it first began, if you have a really small number, the sign in the first quadrant is the y value. It's positive. Yes? When you multiply it by that negative 2, it becomes negative. And that's why the particle started going left first. If the velocity is negative, the particle is going left. If the velocity is negative function mode, the parent graph's going down. Okay? So that's up there, and you're going to problem number 9, which is much closer to the example than 5 was to example 1. Now, if you're at home, you're going to do 9. You're going to watch us go over that. And then you are leaving after we go over 9, and you're going to AP Classroom to do the exit ticket. All right, so here's where we are. We have the cosine of what's inside the parentheses. What's inside the parentheses, pi over 2 is a constant. That's a number. That differentiates to 0. This derivative would be a negative 3. Then what? Cosine differentiates to negative sine. So we have negative times the negative 3 is a positive, 3 sine what's inside the parentheses. That'll be your velocity. Done. Okay? So that's it on the video for 3.6 alpha.